Unit 2, but here it's in the context of shape, and I'll do some shapey ones when I can. Just to remind you how to do this. Question 1a, I've got to factorise this expression here. 8c plus 4, well, the common multiple of, the common factor, the highest common factor of 4 and 8 is of course 4. So if I take a 4 out, I put a plus in there. 4 times what makes 8c? Well, that's 2 times c. 4 times 2c is 8c, and 4 times 1 makes 1. Alright, just revise your Unit 2 stuff. Let's jump over to D. I've got 24 plus 18k. Don't take 2 out because you want to take the biggest factor. 6 goes into these as the biggest factor, so take a 6 out. Open up the bracket and put a plus there. 6 times 4 makes 24, so that's 4. And 6 times 3 makes 18, so I want 3 k's there. Again, you can always check yourself by multiplying out to see if you got it correct. Alright, let's just do G, more complicated one. 12xy minus 9y squared. Grade D, I think it's grade C actually. Now let's just have a look. I've got a bracket, got a minus there, so I'm setting it all up. Highest common factor of 9 and 12 is of course 3, so I'm taking a 3 out. But look, I can take a y from that and a y from that. So therefore the highest common factor will be 3y for these two terms. 3 times 4 makes 12, so I want a 4 there, and I also need an x. So check it. 3 times 4 is 12, x times y times x is just xy, so that's simple. 3 times 3 makes 9. In order to get y squared, I need to have a y inside the bracket. So let's just check it. 3 times 3 is 9. Y times y is y squared. Altogether 9y squared. So I know it's completely correct. I'll do the last one. Looks very complicated. It's worth having. So 36. I think it's f squared k. No, it's f squared times k. Or is it a j? I think it's. I can't tell. Yeah, let's just go for j. So I don't want to get it wrong. So let's just rub this out. That should be j squared. So j squared times k. Makes sense. jk. You know the way maths books are run. And then I've got to take away 30j k squared. Very, very confusing, but be careful. Right. Who can I nick from 36 and 30? I reckon 6 is going the most, so take a 6 out, get my bracket started and put a minus there. Right, can I take a j from each? Yes, I can. Can I take a k from each? Yes, I can, and no more. So the highest common factor is 6jk. So let's have a look. 6jk, how do I get to 36? Well, I need a 6 for a start. How do I get to j squared? I need another j. So study it. 6jk times 6j is 6j squared k, and it exactly fits that. How do I get from 6 to 30? I need a 5 somewhere. I've already got my j's there, so it's not a problem. I've already got my k's there, so it's not a problem. But I want k squared, so it's got to be 5k. Let's just test it. 6 times 6, 36. J times j, j squared, and a single k on its own. Testing this one now. It's more tricky. 6 5s, 30. Of course it's minus 30 because it's a negative value. And j is on its own, single j, and k times k is k squared. Yep, definitely got it. Give me 3 marks for that. Now here's where the shapes kick in now. So again, as is usual, a rectangle. I'm told that's 3, and I'm told the area is 6x minus 21, and I've got to find the missing length, question mark. Well, look, essentially if I factorize this, so if I factorize it, I've got 6x minus 21. The highest common factor of 6 and 21 is 3 anyway, so if I pull a 3 out, I've got the length, and I'm left with 2x's minus 7, because 3 7s make 21. Let's just check it again. 3 times 2x, 6x. 3 times 7, 21, but it's negative, hence that. So therefore, the length across the bottom is going to be 2x minus 7. If I was to multiply these out, I should get my 6x minus 21 back. Let's just do the next one. Well, one of them anyway. I've got a little rectangle in red, actually. That's called P, and I don't know what that's going to be yet, but the area is going to be 7p squared minus 5p. 5p. So here I go, factorising this. 7p squared minus 5p. The most I can take from that is a single p from each term. So it's p bracket, set it all up. I need a 7 to make 7p. I need another p to make p squared. So p times 7p, 7p squared, that's correct. And to get 5p, I need a 5 inside my bracket. 5 times p, 5p, or p times 5, 5p, but it's negative because it says so. And that's it. So essentially, whilst my height or width is p, my width is going to be 7p minus 5. And that's easy. Can't bother with the last one. Now question 3, there's no shapes involved, but these are partly factorised anyway. They're quite annoying. I'm being given this. I've got 10p minus 8 equals question mark times 5p. Now I don't know whether they bother honestly, minus 4. Now clearly to get that, the common factor of 8 and 10 is like 2. So if I just ditch that stupid question mark, I've got 2 lots of 5p minus 4 are going to make the 10p minus 8 if I multiply that. So essentially they've factorised it slightly for me, and I've got to find the other missing factor, which is really dull. How about you factorise it normally and just get the answer straight away? I can't be bothered with the rest of them because it's too silly. Question 4 involves a shape, so I'm going to do it. And here we go with the rectangles again. Factorise fully the expression for the area of these rectangles. Well, the area is going to be, for this one, question 4a, 5g plus 10gt squared. So if that's the area, if I fully factorise it, I can work out the length and the width in any order that it comes. So let's just get factorising. Common factor, 5 and 5 out of each, and a g from each. So if I take out a 5g, I go bracket, bracket plus. 5g times 1 will make 5g. 5g to 10g, well I need to multiply by 2, and that gives me 10g so far, and I need a t squared sitting in there, otherwise I won't get 10g squared. So altogether then, 5g times 1, 5g, 5g times 2t squared, 10g t squared. And so I presume this is going to be 5g across there, and this is going to be 1 plus 2t squared. It doesn't matter if you was to put the 1 plus 2t squared as the width and the 5g as the length, it makes no difference whatsoever. Thing is, if you were to multiply them out, you would get 5g plus 10gt squared, so that's correct. I think I'll do the last one because it looks the most challenging. So well, not really, but let's just do it anyway. I've got a skinny rectangle and the area is 5a, this is quite hard to read, I really can't read this, 5a squared bc squared plus, I'm going to burst outside the rectangle, plus 5ab squared times c. Alright, sorry I've crashed outside, but anyway I'm just going to factorise a stupid thing and let's do it. Well, 5 and 15, biggest factor is 5. I could take an a from u and an a from u, so I will. I could take a b from u and a b from u, so I will. I can take a c from u and a c from u, so I will. Now these are the leftovers. Hopefully I can make it fit. Right. To get a squared, I need another a. To get c squared, I need another c. Let's just study it. 5abc times ac will give me 5a squared, because the a times a. I'll get my b because it's sitting outside anyway as a factor. It's part of the factor. And c times c is c squared. So that works. Now, 5 times 3 will give me the 15. I've already got my a outside. I've already got my c outside. So to get b squared, I need to have just a single b. Alright, so let's just recap. 5 times 3 is 15. And over there I've got a single a. And then b times b is b squared, so he's happy. And then I've got a single c. So that, friends, is that expression fully factorised. And when they say things like fully factorised, it usually means, watch out, take out more than just the obvious 1 or 2 terms. There's more factors that could come out. So let me just write here, factorising fully. That means go as far as you can, alright? Squidgy, squidgy, squidge. Factorise fully. and you need to study this one because it's quite complicated. What's this? I really fancy question 7. I hope it's going to fit on the video. It's quite complicated, but it looks really nice. I'm given something like this. If you look at question 7 as a demo, it's done for you, but for 7A, it's absolutely beautiful. It's so lovely. I'm going to do it myself. It's I really fancy doing a puzzle. I've got this. I've got 15y minus 10y squared. Hope we don't get these in the exam. Then I've got a box there, and then I've got a box there, and then I'm told to factorize it. In other words, factorize. Okay then. And then I get my two factors, and then I'm going to merge them together, and then it says add. So I've got to add them up. Fine. And then I've got to factorize it again. How cruel. Get a factor in there, and a factor in there. So that's factorize. And last of all, I've got to take my two factors and add. So let's have some fun then. Right, here we go. You can call it fun. Let's factorize this expression here. Right, 10 and 15. The most I can nick is a 5 and a y. Okay, that would be 3 minus 2y. Study that one. 5y times 3, 15y. 5y times 2y, 10y squared. Alright? So I've now got to put my answers back in this little box. So I've got 5y, having factorized it, and here I've got 3 minus 2y. Then I'm told to add them. Alright then, so I've got 5y minus 2y, let's just write it down. So I've got 5y plus 3, and then let's get the order right, yeah? So here I go, 5y take away 2y is called 3y, and 3y plus 3. So here I go, that's my answer, 3y plus 3. And now I've got to factorize it. Oh great, here we go. So I've got 3y plus 3. It's going to get easy, isn't it? Take out the common factor, which is 3. So I'm left with y plus 1. So here we go, 3 for you, and y plus 1. Now I've got to add them again. Okay, y plus 1 plus the 3 up there. What have I got? I've got y plus 4. Are you happy now? Good. And there's loads more to try like that. What it is really, it's just an excuse to play with factorizing, adding, getting another expression, factorize it again, then add it, and then you arrive at a situation where you end up with a term which can't be factorized or simplified any further, and so you stop. There's no obvious link between the answer and the original question. You wouldn't necessarily work backwards to find that connection at all, but it's just a nice, neat way of playing with basic algebra and practicing your grade C skills. So I won't do any more of that, and therefore I think I'll stop and have a breather.